Hello guys, I am Parinita and welcome back to my channel to polish your CSE concepts with me. So let's get started. You must have seen in our previous videos, we have seen the method to identify if a grammar is LR0 or not. We have seen the method to see if a grammar is SLR1 or not, LL1 or not, right? We have already seen those things. Now in this video, we are taking one example. This is actually one of the standard examples. With the help of this example, we are going to check this example and see if this given grammar is LL1 or not, LR0 or not, and SLR1 or not. So kind of it will be a quick revision for you, and on the same grammar we will be checking all these three things. Fine. So yes, without wasting any time, let's start it. As you know, for LR0 and SLR1, LR0 and SLR1, the canonical, we have to develop or make the canonical items of LR0. Fine. So that is common for both of these. So let's start that. And as you must be knowing that for LR0 and SLR1, the only difference is filling their parsing table. So at the time of filling the parsing table, we will take care one by one. We will do it for SLR1 and LR0. But for now, first of all, our main task is we are making the canonical collection of LR0 items, and that is going to be same in case of both LR0 as well as SLR1. Fine. So yes, let's start it. What is our first task? First of all, the main thing that we are doing is adding one augmented grammar. What is augmented grammar? This is S. So this starting symbol S will come in RHS. That means I will make one augmented grammar S dash gives dot S. Fine. Now after dot I am having one variable. So I have to write all the productions of this variable, that is S gives dot L or dot X. So that's it. Again, now after dot I am having only terminals. So I don't need to proceed further. This will become my first state. Okay. Now after dot I am having S. So I will have one production from here for capital S. That will be S dash gives. Dot will be shifted by 1. So S dot. And this is my second state. I will have my third state for this opening bracket, because after dot opening bracket is there. So S gives opening bracket, then dot L this. Now here after dot I am having one variable or non-terminal, so I have to write the productions of this variable capital L. So L gives dot L comma S and L gives dot capital S. Now again after dot L is already there. Now again after dot we are having capital S. So I have to write the productions of capital S also. So capital S gives dot L or dot X. Fine. So this is my third state. Okay. Capital S is completed. After dot this opening bracket is completed. Then I am having after dot X. So I have to write a production for small x. S gives dot will be shifted. So X dot. This became my fourth state. Fine. I don't here dot is at the last position. So I don't need to expand this state anymore. Here dot is at the last position. I don't need to expand this state also. But yes, this state we can see that there are many variables and terminals after dot, so we have to expand it. First of all, we will be doing for capital L. So expanding it for capital L, what I will get, S gives dot will be shifted one side right. So bracket L and then dot closing bracket. Fine. Dot will be shifted one side right. Okay. Now here also we are doing for capital L. So here also dot will be shifted after L. So L gives L dot comma S. Fine. Okay. That's it. Here after dot terminal is there. Here after dot terminal is there. So I don't need to expand it any further. This became my next state. Okay. Capital L is done. Now I have to parse capital S. So I will be writing for capital S. Dot will be shifted one side right. So L gives S dot. Okay. Capital L is done, capital S is done. Now I have to write for opening bracket and X. Now for opening bracket, L gives, dot will be shifted one side right. So bracket dot L closing bracket. Bracket dot L closing bracket. Now here after dot we are having one variable, so I have to write the productions of this variable also. So L gives dot L comma S or dot S. So this is one of the states that I got. Fine. Then I am having X. So what I will get after parsing this X, dot will be shifted one towards right side. So I will get S gives X dot. Now S gives X dot is already present, so there is no need to make one new state. So I will just do the arrow here for small x. Fine. So all the productions, all the parsing from this state is done. Now we will move further. Here dot is at the end, so I don't need to expand this state. Fine. But yes, I again have to expand this particular state. So let's expand this state. Okay. Now for closing bracket. For closing bracket, if I work, I will get S gives closing bracket and then dot. Fine. Here again we got dot at the end, so I will not proceed it further. Now here after dot we are having comma, so here comma. Okay, this is comma and this is closing bracket. Fine. Okay, for comma I am parsing, so dot will come one side right, so I will get L gives L comma dot S. Now after dot we are having one variable, so I have to write the productions of this S also. So S gives dot L or dot X. Fine. Okay. This is a new state that we got. Okay. Now here dot is at the end. We don't need to proceed it further. But yes, here we have to proceed. Here after dot I am having capital S. So we will be having one production for, we will be having one new state for parsing capital S. So I will get what? L gives L comma S dot. So here again I got dot at the end. No need to expand it further. Then here again I am having after dot opening bracket. Okay. So I will get, for opening bracket, what I will get? S gives opening bracket dot L closing bracket. It is looking something like this. See, S gives, if I parse opening bracket here, dot will be moved one side right. So I will get S, see, S gives opening bracket dot L closing bracket. Fine. So I will get something like this only. So this is again redundant state. We don't need to make it again. We will just make our arrow from there to here, and we are parsing what? After dot S is there, so we are parsing it for capital S. For bracket, opening bracket. So for S is done, for opening bracket is done. Now for X. For X, what I will get? S gives X dot. Is it already available or we need to make it? Okay, this is also available. So we will not make it again. We will just do a arrow here for small x. I guess we are done now. Just check quickly if anything is left. No, I guess it's done, right? So let's give the state numbers. This is I0, I1, I2, I3, I4, I5, okay, just a second. Here see, here after closing bracket, this should be after closing bracket. Here see, after closing bracket is here. So S gives opening bracket and this, here S is there, right? Here we are parsing this opening bracket. That means dot will be after this. So S gives opening bracket dot L this, yes, and if we see here clearly, then S gives opening bracket dot L bracket. So I guess this is the same state. So instead of making it again, there is no need to make it again. You are understanding? It is going to the same state. So what we can simply do? We can simply make the loop to itself. For what? For opening bracket. Right? For opening bracket, we can loop it to itself. So I0, I1, I2, I3, I4, I5. Okay. Then this will become my I6. This will become my I7. And this is my final state, I8. So total how many states we got? 9 states. 0 to 8. Fine. So this is the whole canonical collection of LR0 items that we have made. This canonical collection of LR0 items, we are going to use it in both LR0 and SLR1. This will be common for our both the parsing. Fine. Now what is my next step? My next step is to make the parsing table to check whether the given grammar is LR0 or not, SLR1 or not. Fine. So we are going to make the parsing table. How to make the parsing table? We know how many states we are having here, 0 to 8. So we will write it. So let's make parsing table here. You can take a snapshot of this graph so that if I am moving down, you can have this graph with you. You can take the snapshot of this and then verify it with the table that we are making. So what will come here in the vertical places, we will be having the state numbers, that is 0 to 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Fine, we are having 8, total 9 states I mean. Okay, what will come here? We will be having action and go to part. As you already know, we will be having action. In action part, here we will be having opening bracket, closing bracket, X, comma, and we will append $1. Fine, this is our action part. Then for go to part, what I will be having? Which are the variables present in our grammar? Capital S and capital L. That's it. So this is how we will make one parsing table. Now first of all, let's do it for SLR1. Fine. We are doing first for SLR1. Okay. So from 0 on opening bracket. From 0 on opening. Okay. Let's go flow wise. From 0 on capital S, we are going to I1. From 0 on capital S, we are going to state 1. From 0 on opening bracket I2. From 0 on opening bracket 2. So from 0 on opening bracket we are going to 2. In action part we are writing it as S2 because it is a shift move. From 0 on X. From 0 by X we are going to 3. 0 on X we are going to 3. Fine. So that's it for 0th state. Now for first state. Now I am assuming that you have taken the snapshot of the graph or you have made it in your notebook or any notes so that you can check from there, and I can see this, so we can make it directly. Okay, from first state, from state number 1. Okay, what is state number 1? It is S dash gives S dot. So this is what it is, the acceptance state of the augmented grammar that we have written. So in I1, what we are doing in such cases, only under dollar we will write accept. So in the first row in the dollar column we will just write accept. Okay, now check the state number 2, I2. Okay, on I2, on capital bracket we are going to 2. So shift 2. From 2 on X 3. On X 3 means shift S3. On 2 with the help of capital S we are going to 5. On the help with the help of capital L we are going to state number 4. Okay. Okay, now see the state number 3. On 3 on capital bracket. Okay, what is state number 3? See, state number 3 is S gives X dot. What is this? This is a reduction move. Here dot is at the end. That means one state is reduced here. One production is reduced here. So it is the reduction move. Let's number our productions. Let it be 1. Let it be 2, 3 and 4. Fine. So S gives X dot. It will be S gives X dot. My production number second. So I have to write R2. Now first of all we are making for what? First of all we are making for SLR1. So what happens in SLR1? The rule is we have to write the reduction moves. We have to write this reduction move in the follow of LHS. Means I have to write this reduction move in the follow of S. Now in this case, what is the follow of S? Follow of S. Follow of S here, it is the last symbol. So follow of S will be equal to follow of L. And what is follow of L? Follow of L is opening bracket and comma, right? Follow of L is opening bracket and comma. So let me write it somewhere so that you can understand. Here if we talk about follow, then I am getting my follow of L is simply opening bracket and comma. Now we have seen that follow of L, we have seen that S is the last symbol here. So follow of S will be equal to follow of L. So follow of S will become what? Opening bracket, comma, and as well as it is the starting symbol, in the follow set of the starting symbol, always we are having the dollar. So extra we will be having dollar. So follow of L is only these two and follow of S is these three including dollar. Fine. Okay. Now what we have seen, I3, state number 3 is a reduction move. Reduction number 2, S gives X dot, it is reduction number 2. So I have to write R2 in the follow set of S. Means I have to write R2 under opening bracket, comma and dollar. Right. So I will be writing that. Opening bracket, comma and dollar. Fine. We have written these two R2 reduction moves. Now what is 4? See the state number 4. From 4 on opening bracket we are going to 6. S6. From 4 on comma we are going to 7. That is S7. From 4, okay, that's it. So this is all about our 4th row. Now see the state number 5 for 5th row. Again 5th row is L gives S dot. L gives S dot is my production number 4. So I have to write R4 under the follow of L. What is the follow of L? Opening bracket and comma. Opening bracket and comma. Fine. Now again 6th state is again reduction move. S gives opening bracket, L closing bracket means R1. So I have to write R1 in the follow of S. So I will be writing R1 in the follow of S. Follow of S is these three. Okay. Then 7, from 7th state on capital bracket we are going to 2. On X we are going to 3. And on capital S we are going to 8. Okay. Now from 8th state is again reduction move. This one R3, so I have to write R3 on the follow of L. So I have to write R3 in opening bracket and comma. So that's all about my SLR1 table. So this is what this thing that I have constructed. It is my SLR1 parsing table. And what the condition is, in the SLR1 parsing table, if we are not having any kind of conflict, then I can simply say that my given grammar is SLR1. So yes, this grammar that is given here is SLR1. I can simply say that. So we have checked that. Now we want to check for LR0. Now what changes we have to do for LR0? Nothing much. We just know that for LR0, the only difference between SLR1 and LR0 is that in LR0, whenever there is a reduction move, it will be placed inside all the columns of action part. So for example, here R2 is there. That means what? We don't need to change anything in the table. The only thing we have to do is, whenever there is a reduction move, we have to place it under all the columns of the action part. See, this is R2 reduction move. So this is remaining here. Here also we have to put R2. This is R4, so in these two remaining places also we have to put R2. And this is R1, here also I have to put R1. This is R3, so in these two places also I have to make R3. So yes, if you consider the only black part, this is my SLR1. If you consider the black plus blue part, this is my LR0 parsing table. And even if writing the reduction moves in all the cells of action part, that means in LR0 also there is no conflict at all. You can see that. What is conflict? If in any cell I am getting more than one value, I can say that it is conflict. But we are not getting conflict anywhere, so I can say that the given grammar is LR0 also. Fine. So the given grammar is SLR1 and LR0 both. Now let's quickly check whether the given grammar is LL1 also. LL1 also or not. So how to check that? I have shown you in one of my videos. I have shown you the shortcut also. If you have not seen that, please see that. It will be helpful to you. So how we can directly check that whether my given grammar is LL1 or not? For LL1 or not, we just have to check that for every production where it can be written. So if I talk about this grammar, S gives this. So where the first production will be written inside its first, and its first is opening bracket. Where the second production will be written, it is only X, it is a terminal, so it will be written in that terminal only. So inside the row of S, this will be written in the column of capital bracket and this will be written in the column of X. So these both will be written in the different cells. So no conflict in this. Now coming here, L gives this. Okay. Now where this production will be written, L is a variable. The first of this is L. L is a variable, and whenever, see here, both the first of this is capital bracket, this is terminal, so we have written directly in this. Here it is a terminal, so we are writing directly in this. But if we talk here the first of L comma S is L, that is a variable, so I have to write this in the first set of capital L. What will be the first set of capital L? It will be first of, okay, here first of S is capital, is opening bracket and X, and first of L will be equal to first of S, and that will also be capital opening bracket and X. So this will also be written in opening brackets and S, and this production will also be written in opening bracket and X. So yes, in this case we will get a conflict because this both the productions will be written in the row of capital L and in the column of opening bracket and small x. So yes, in case of LL1 we will get a conflict. So we can say that the given grammar is not LL1. So even if our given grammar is LR0 and SLR1, but it is not LL1. Fine, so this is one of the very standard examples, and so I have shown you the whole method, how to solve it, how to make the canonical collections of LR0 item, and how to, I have also shown you by checking whether grammar is LL1 or not, LR0 or not, and SLR1 or not. I hope all of these concepts are clear now. Thank you.